Problems like these should be pretty familiar to you now. You read something like N-ethyl-aniline, and you should look for the root of the name. But you see aniline and say, I don't know what that is. So you do a web search for aniline, and you discover that it's a benzene ring with an amine attached. The N we've seen before with amides. That tells us that this ethyl group is attached to the nitrogen, not somewhere on the benzene ring. So we attach our ethyl group. We look at our nitrogen and say this just has two things bound to it. So we put on the hydrogen. This next one, 2,6-diethyl-aniline. Okay, the root is aniline, and we looked that up. Discovered it was this molecule. Hold off on putting the H's till I see what groups are attached. 2,6. I think this is an impossible. Oh no, it works. Okay, 2,6. This is 1. We go to 2, add an ethyl group. 3, 4, 5, 6. Add a second ethyl group. All right. All these problems have aniline, so we draw our aniline. P, your reference sheet may remind you what O, M, and P are. P means across, means para, so we put an ethyl group across from the aniline. We need to make sure our nitrogen has 3 things bonded to it, so we add 2 hydrogen. And I go back to my previous one and fix that problem by adding the hydrogen. Fourth one, again aniline. Now we've got 2 groups attached to it. NN, dimethyl. They're both methyl groups. The nitrogen has 3 bonds, so we leave it alone. Do you remember the shape of nitrogen? Do you remember how many lone pairs? You could always add those in, and you have a trigonal pyramidal group right here, along with your flat planar benzene ring.